Welcome to this Sto Glass Rainscreen CPD video, which is in two parts. In this, part 1, we cover rainscreen principles, the difference between a glass rainscreen cladding system and curtain walling, and the cladding material that can be used for a rainscreen system. The system benefits, colours and finishes will also be presented in depth to help you when designing a glass rainscreen system. Part 2 explores performance and approvals, including moisture protection, wind loads, impact and blast performance, and fire safety. In 1954, Fritz Stottmeister, the founder of the Sto Group, discovered a newspaper advertisement looking for a licensee for a new type of organically bound plaster, and convinced his father to invest. The new material quickly became a success, and the Sto brand was born, including the iconic yellow bucket. 2 years later, the company launched Stotherm Classic, and with it the story of facade insulation, which soon developed into Sto's core business field. Sto grew from a regional plaster and paint manufacturer to a leading international group of companies. Today, the group has 50 subsidiaries in 38 countries and employs over 5,700 people. Our business is known first and foremost for our cement-free plaster render finishes and reinforcement, which, when used as part of our external wall insulation systems, EWIS, and rainscreen cladding systems, offer a huge choice of attractive, durable, energy-saving, and hence cost-effective options for refurbishment or new build construction. In addition to our comprehensive range of facade renders and intelligent technology paints, we also offer a portfolio of sound-absorbing acoustic systems, solutions for concrete restoration, and interior coatings. Let's start with a brief history on rainscreen cladding systems. The technology comes from Norwegian farmers. They realized that cladding their barns with wood and leaving a ventilated cavity meant they could stop moisture damage. This is why rainscreen cladding was originally referred to as the open-jointed barn technique. It wasn't until the 1940s that the results of the Scandinavian investigations using timber cladding were incredibly positive, rainscreen cladding being recognized as vastly superior to other building methods of the time, a fact that still largely holds true today. One of the most publicized examples of an early rainscreen cladding project was the Alcoa building in Pittsburgh, US. Built in 1952, the 30-story building was clad in open-jointed aluminium baffles. It wasn't until much later, around the 1970s, that rainscreen cladding became a popular building method. What is a rainscreen cladding system? Rainscreen is a form of double-wall construction, and the outer layer keeps most of the rain out. A drained and ventilated cavity eliminates the remainder of the moisture by natural drainage and evaporation. The cavity creates a natural chimney effect, pulling the air through from bottom to top. The inner leaf provides thermal insulation, prevents excessive air leakage, and carries the wind load. Some systems may be designed with pressure equalization, whereby the positive air pressure in the cavity prevents water blowing into the joints. These systems are fairly rare, and a limited form of this effect may also be experienced with drained and vented systems, albeit not intentionally designed in. There are two main types of non-structural architectural glass systems: curtain walling and rain screens. Curtain walling is completely sealed against the weather. Rainscreen cladding has open-jointed panels and a ventilated cavity and is mounted on a substrate that provides the primary defense against weather ingress. In this CPD video, we're covering glass rainscreens. Here's an example of a build-up of a typical rainscreen cladding system. The substrate, which can be solid or sheathed steel frame. Then the mineral fibre rainscreen slab insulation, thickness to suit U value, is fixed to the substrate with dowels. A subconstruction is then fixed to the insulation, which comprises stainless steel wall brackets, aluminium vertical and horizontal profiles, and fixings to suit the substrate. The outer leaf glass panel is typically 6 mm thick toughened glass bonded to a backing board. Thicker glass is available for applications where the panels are particularly large. Some glass rain screen cladding systems require clips or through fixings to resist wind loadings. The panel consists of 3 elements. The outer layer is a 6 or 8 mm heat-soak tested safety glass that is coated on the rear face with a mineralic pigment. The glass thickness is related to the size of the panel. The pigment is applied during the toughening process and baked into the rear surface of the glass. This means it can't be scratched off and will not fade. The safety glass is incredibly tough. Given sufficient impact, it shatters into small, safe chunks, not sharp shards, and remains bonded to the backer panel. The adhesive layer bonds the glass strongly and safely to the backer panel. It ensures the glass remains bonded and in place, even in the event that it is smashed. The backer panel is manufactured from perlite and forms a strong and stable platform for the glass. It is very dimensionally stable, not expanding, contracting, or warping under heat, cold, or moisture. The backer panel also forms a stable background for the horizontal carrying profiles that are screwed through onto the rear face. Glass panel sizes start at a base of 2.6 by 1.25 meters, and this is the most economical size. The largest panel size in terms of area is 2.6 by 2.5 meters. For horizontal format, the largest format is 1.5 by 3.75 meters. 8 mm glass is used for lengths over 2.8 meters. For vertical formats, the largest size is 3.75 by 1.5 meters, which can increase to 4.5 by 1.25 meters. Again, 8 mm glass is used for heights over 2.8 meters. Smallest formats are 175 by 250 mm horizontally and 250 by 100 mm vertically. Also, non-rectangular shapes are possible, as well as curves and arcs. Glass is not only a remarkable material in terms of appearance, but also its design flexibility. You can choose single color, multicolor, or metallics for your bespoke design, with a variety of finishes available. Textured glass is also available, adding a 3-dimensional element to the surface. Glass rain screen panels are generally colored. It is important to choose a system where the colors are fused to the back of the glass and applied before the toughening process. The colored enamel melts into the glass at over 600 degrees Celsius. This enamel is color-fast and permanent. Avoid painted glass, as this may not be as durable. The color system typically used is RAL, standard colors. There is flexibility to produce panels to manufacturers' color ranges. It is also possible to use multiple colors within the same panel. Traditional standard float glass carries a greenish hue from the natural levels of iron oxide in the glass. It is possible to have colorless toughened glass. This is called OptiWhite. By using the OptiWhite colors, the panel will lose the green hue and reflect the true color applied to the rear of the glass. Screen printing and digital printing offers additional design possibilities. The graphic is fused to the back of the glass and bonded to stop peeling or wear during the enameling process. Patterns, illustrations, photographs, or corporate logos can be designed for the glass panels. The finish of the glass surface can also be varied. Specialist matte finishes are available and tend to carry a surcharge over standard gloss finishes. There are also ranges of mirrored and metallic finishes available with toughened glass panels. Let's look at the different types of finishes that are available for glass panels, showing the textured, digitally printed, mirrored, glossy, and matte options. A huge range of textures are available from different glass manufacturers, and many are suitable for use on glass rain screen systems. Having a bespoke panelized cladding system allows the designer to control the visual interpretation of the building grid. Typically, joints between panels are between 5 and 12 mm. Almost any shape is practically possible to develop. Joints and recesses can be reflected as a design element. Panels must be shaped prior to the toughening process. The surface level of the cladding can also be controlled by using the wide range of bracket sizes that are available. That concludes part 1 of this Sto CPD video. In part 2, we'll cover glass rain screen performance, including moisture protection, wind loads, impact and blast performance, and fire safety.